Hi, everybody. Well, yep, we're talking about plants and animals and us and how water is used by plants, how water is used by animals, and how we use water inside our bodies and everything. So I've got a lot to do, and I hope you have some things from the gather ahead of time list. We're going to start with plants. So plants are amazing. They use lots and lots of water, and there's water inside of plants. Trees, our vegetables, everything that grows here on Earth uses water usually. So if you have some celery, gather that together right now, and I'm going to show you how that we can make an experiment that shows how celery sucks up water through its stem. I did this last night. I had some older celery and I stuck it in some containers and I put in some dye, and look what happened. So if you're just starting your experiment right now, it's not gonna show for another couple of hours, but I'll show you how to put that celery experiment together. So first of all, I'm going to change my camera to the tabletop and show you how to make a celery experiment. There, I started with some celery. So this is what I did. I took some celery that was almost kind of getting too old to eat, but I wanted to see how celery sucks up water through its veins. So what I did was I took a little knife, and you can use a plastic knife too, and I cut the very end of my celery off so that I would have a new end, so that would be fresh and it would suck up the water. So if you have a hand lens or a magnifying lens, you can take a look at the end of your celery stem, and if you hold it just right, you can see the veins in that celery stem. And so what I'm going to do is show you that again. I'm going to use this one and stick it in some water because I just cut it. But what I'm going to do is I'm going to cut this piece of celery. And I know if you've ever eaten celery, you can actually see the cords in the stem and chew on them. See, look at that. Each one of those celery strings, I call them, are the veins that celery uses as it grows to suck up water into its stalk. Yeah, there we go. So when we cut the end off of the piece of celery, like we did just a minute ago, you can use a hand lens to look at those ends and see how that celery pulls the water right up from the very end all the way to the tip, where sometimes there's leaves. This one's too old. The leaves kind of died. So we cut off the bottom, and then if you want to put it in a big tall, you can use a glass, you can use a canning jar, or whatever you have. I'm going to use this glass right here, and I'm going to put some water in it. Fill it, maybe a little ways up. Couple inches of water in there, so that when you stick your celery in there, it'll be able to suck up that water. So how can we tell if that celery is going to suck up the water? Well, we're going to put some dye in it. And I liked, if you have some red food coloring, I have some red liquid watercolor, but if you have some red food coloring or any color food coloring, the next thing to do is drop a bunch of that into the water so the water is colored. There we go. So how does celery use water? It sucks up the water through the veins that we were talking about. So there, I put a whole bunch of pink or red dye into my water, and then I'm just gonna let this sit for, you can start to see it after about a half an hour. You'll start to see some of the veins in that celery pick up the dye that you put into the water. And so I'm going to go back to the regular camera and let's take a look at the celery that I did yesterday, just so it would show up really good and we could take a look. So the results of your experiment that you just started today by cutting off the celery and sticking it in a jar, and you can do as many colors as you have and see what happens. So here's the results of my experiment. I started to show that to you earlier, and there is my celery. Now I put this one in blue. Check that out. And you can see that when I added blue dye to the water, you can see the tips of the leaves have started to turn blue. And because celery is green already, when you add blue to green, it even looks greener actually on camera. And can you tell which stalk of celery I put in the pink dye? I'll hold it up now, but check that out. Whoa, the leaves started to turn. They have little pink tips, little red tips. And then the last color that I use, I thought it was pretty cool, was purple. And I can sort of see the tips of the leaves have turned purple from sucking the water up through the stalk, up through the stem, and into the leaves. So you can see how a plant uses water. It's got to have water to grow. It's got to have water to live. And actually, this piece of celery was all wilted and terrible before I stuck it in the water. And now it started to branch out. So when your experiment starts to suck up the dye, you can use your hand lens and take a look at the leaves or your stalks up close, and you can see how it pulled the water up through the stems and into the leaves. Now I did something kind of fun and special too. I did one celery, I'm going to show that to you. I did one celery and I cut the stem in two. I split it. I had a stalk of celery, and I'll show you how I did that. Oops, we'll cut it here. All right. I had one single stalk of celery, and I took my knife and I split it down the middle, just like this. And I put one stem in blue, and I put the other stem in pink. Whoops, it just flopped over. Just a minute. There we go. Just like that. I put one in blue and one in pink. So this is just a suggestion when you do your experiment. And look what happened. That was one stalk, and the blue side turned blue and the red side turned red. So that was kind of fun to watch. So watch, that's how you do your celery experiment, and you can watch it as it progresses. In about half an hour, you should be able to see some color move up the stem and the stalk of your celery. And you can do as many celeries as you have color. I did 3 because I had 3 colors, and see what it looks like as it pulls the water up through the stem. That's what plants do. Okay, so now we're still thinking about plants, and I have a great big pan of different foods that I collected from my refrigerator. And one of the things that I had you guys bring with you today is an orange. So let's find out if there's water in an orange. I kind of think there is. So this is what we're going to do. Back to the tabletop camera. We are going to we're going to cut the orange in half. So if you have an orange, the question is there water inside an orange? Because an orange is a plant, it grows on a tree. And so we're going to cut the orange in half. Anybody out there drink orange juice? I do. Oh, you know what? I forgot. This is a blood orange. This is really going to look silly. It's kind of like oranges that almost looks like a red grapefruit. Yeah. So oranges are pretty much orange. A regular orange would be all orange inside. But let's squeeze it. into this little cup and see if there's water inside. Whoa! Yes, there is. Check that out. So inside lots of plants, parts of them have concentrations of water. Whoa, plants. There we go. I forgot this one was a blood orange. I bought it because I wanted to see what they tasted like one day. Whoa, there we go. So yes, there is water in an orange. Okay, let's see what else I have. I have some grapes. So if you have anything inside your refrigerator like grapes, let's see if there's water inside grapes. I'm going to cut that one in half. Okay, get out another little cup and squeeze it. See if I can get a drip coming off of that. Whoa. Yep, I did. Did you see that? I got a drip. I'll do it again. Whoa. Drip, drip, drip. I got a bunch of them. Whoa. And it feels really wet on my hands. So, yep, there's water in grapes. I'm going to eat that one. Yeah. There's water in grapes. In fact, what is a raisin? A raisin, some raisins. A raisin is a grape with all the water dried out of it. So lots of plants, suck up the water and use water. Of course, we eat them as food. Okay, so let's try. I got a tomato. I'm gonna eat the other grape. I'm gonna cut a tomato in half. Let's see if we can get some water. If there's any water inside a tomato. Whoa. Cool. It looks a little juicy. So here's my cup again. And I'm gonna squeeze my tomato. Ooh. Oh, I got drips. I do. Can you see that? There we go. I got drips and seeds. But yes, there is water inside a tomato. And if you wanted to dry out a tomato, it would almost look like a little red raisin. I've got some sun-dried tomatoes here. I'm going to get one out so you can see. I had blueberries. I had grapes. And there. That's what would happen if you dried out a tomato and take all the water out of it. Whoa. So yeah, plants have lots of water inside them. Okay, well, I'm making a pretty good mess here. Here's something that you can try. If you have any lettuce or spinach, and this project will go on for a little while. If you have any lettuce and spinach, you can just let the leaf sit out on a little plate and watch how it dries up over time. Might take a couple of days. It might wilt first, but all the water will dry out of that leaf if you just let it be. And see what happens when a plant loses all its water. Right now, this little spinach leaf, if I took and mushed it in my fingers, it would start to feel wet between my fingers. Oh, and because spinach is green, I'm getting a little green. But you can see I'm squishing and mushing the water that's inside this leaf. You can do that with tree leaves too, in the summer and spring when the leaves are on the trees. You can squish them and actually see the water that's inside the leaves and plants. There we go. Okay, so I'm going to put that one back and let's move on because we've got lots of fun things to do. Oh, my blood orange is dripping all over the place and my celery is wilting and my grapes are squishing. So let's move that out of the way. Okay, so plants. Whoa. So let's start to think about animals. We found a lot of water inside plants, but let's think about animals. So today, I hope you brought with you, we're going to talk about polar bears. Oh, I have my polar bear puppet right here. And I'm going to go back to the FaceTime camera. Okay, I got my little polar bear right here. And I don't want to get my blood orange juice on my polar bear. But animals use water too, in lots of different ways. Can you think of any animals that live in the water?
Fish.
Fish? Right. Oh, for sure. And polar bears, they swim in the water up north where it's really, really cold. And they need water because they catch the fish that you were talking about. They catch fish and they catch seals and all kinds of things to eat. So how do they stay warm? They need water to swim in. So we're going to pretend that this bowl is what the polar bear swims in. Of course, I don't want to get my puppet wet, but we're going to do an experiment with a big bowl of water and some ice to see how polar bear keeps warm, because polar bears have to have water to survive because that's where their food is. And they're always in it, and it's always cold because it's way up north. So if you have a big bowl and you have a Ziploc bag and you have some ice and some shortening, some vegetable shortening, that's greasy. So we're going to do an experiment with all of those things. So the first thing I'm going to do is pour a little bit of water in the bowl. And you can do that if you have a bowl. Pour some water in. And I have all I need in here already. So now I'm going to add some ice to make it really, really cold. I got some ice here on the floor. And I'm going to put in a whole bunch of ice cubes to make my water really, really cold. There we go. Whoa. Okay. Okay, so I have my ice in there, and I'm gonna, ooh, that's cold. So after you put your ice in it, you'll wait a second or two, and the water gets colder and colder and colder. And if you were a polar bear, you'd have to swim in icy, icy, icy water all the time. So how is a polar bear? You know, he's got fur, but the fur gets wet, and then how does he keep his body warm? Okay, so now we're going to start the experiment. Take your hand and stick it inside the bowl of icy water and count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh man, that's cold. My fingers are really cold. So obviously I'm not like the polar bear. I wouldn't want to swim in ice cold water, even if I was hungry and I was trying to catch fish. So the next thing we're going to do is we're going to simulate the fat that polar bears have and see how that insulates them against the cold and keeps their body heat inside. So if you stick your hand inside a plastic bag and stick it in the water, you can still feel the cold. But let's add some fat that's going to stand for the polar bear's body fat. So I have some shortening right here. And your shortening, if you have it, is probably white. Mine is slightly off-white because I use it to make donuts with. And then I'm going to reuse it to make more donuts later. But spread some fat. See, there's my hand. And I'm spreading some fat all around that Ziploc bag where I'm going to stick my hand in there. Spread some on the other side. It gets a little messy. Wow. But that stands for the fat that the polar bear uses inside his body as a barrier, an insulator, so he won't feel the cold so much. It keeps the body heat inside that polar bear so he can go hunt seals and fish. Okay, so I've got a bunch of grease on the outside of my bag. So now compare it to how that felt on your bear skin. Hold on to the bag and stick your greasy bag hand into the water. Whoa. Now count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It feels cool to me, but it doesn't feel icy. So that's how the polar bear stays warm. That's how one, now this is kind of messy, so you can turn your bag inside out so the grease doesn't get all over your table, because now the grease is inside the bag. So that's a little trick. Okay, but yeah, so that's how the polar bear stays warm, because the polar bear needs water to survive, but his water is really cold. So that's one really cool example of how animals use water. Okay, so the next experiment, I'm going to put my polar bear swimming pool back over here in the corner of my table. And I'm going to get out some gummy bears. Okay, and let's see. All right, so I have a little dish of gummy bears, and I have a ruler, and I have some cups, 3 cups, and a little bit of water. So now again, I'm going to turn my camera to the tabletop so you can see what we're doing with all of these yummy gummy bears. Here we go. Whoops, come on camera. There we go. Okay, so gummy bears, right? And cups. So what I did yesterday, because I was pretty much sure that it would take a while for this experiment to happen, I took a red gummy bear like this, and I measured it with my ruler, and it was just under an inch long. And I measured it, and it was just about 1/4 of an inch wide. See, there's the long way, and there's the short way. So I measured it. So it was about 1 inch by 1/4. And then, you know, gummy bears are kind of sticky and gummy. There's a lot of sugar in them. And there's a thing in there called gelatin too, like Jello, that holds water. And so then I took my little gummy bear and I stuck it in a cup of water. And it sucked up a bunch of water inside it. So I'm going to pick him up. What? Uh-oh, he broke. Oh, dear. He broke. He's got so much inside him that he broke. So I'm going to have to pull him out. Oh, he's in pieces. Poor bear. And this probably might happen to you too, depending on how long that you soaked your gummy bear. Oh dear. So I'm going to try to put my gummy bear back together. He won't go back. There he goes. Well, sort of. He broke. But there's my gummy bear. So let's compare him to the size of the gummy bear that I did yesterday. Wow! Look what happened. So let's set up your experiment. So later, after a while, a lot of these experiments today are, let's wait and see what happens, but we'll show you how to set it up. So what I'm going to do is, if you have 3 glasses or 3 cups, pour a little bit of water in each one, just like that. And then you can pick out your favorite color of gummy bear. And I'm going to do green this time. So I'm going to get 2 gummy bears that are the same color and stick it in a cup. Whoop. And another cup. Oh, whoops, I forgot to measure them. Yeah, measure them before you stick them in. They're pretty much just under 1 inch and about 1/4 inch wide, just like my red one was. So anyway, measure them before you stick them in, and then it's time to wait. Now, I had a question. I was wondering if the green gummy bears would get any bigger than any of the other colored gummy bears if we soaked them. So I'm going to compare green to orange. So one of them, and I'm going to measure it. Yep, same size. And stick it in there. So now it's hurry up and wait. What do you think will happen? Well, I think what's going to happen is it's going to suck up the water. It's made out of gelatin. You know how gelatin is all jiggly. There's lots of water inside Jell-O. The water goes, there's a little bit of water inside a gummy bear, lots of sugar, but the water goes from the least concentration, or the most concentration, to the least. So the water, by osmosis, sucks into the gummy bear and expands that gummy bear. So there's lots of water in my cup and not a whole lot of water yet inside my gummy bear. So the water moves to make the concentration of water equal from outside the gummy bear to inside the gummy bear. And that's why it gets bigger and bigger and bigger. It sucks up more water, more water, more water. So, yep, that experiment is hurry up and wait. So just like the celery, check that again in about a half an hour and see if the bear got any bigger. And of course, my gooey one soaked overnight, but in about half an hour, these guys are going to be a little bit bigger and you'll still be able to pick them up. And you can put them on your ruler and measure them to see how big he got in a half an hour. And you can probably even do it after an hour. So yeah, there's water inside animals. Not only our gummy bears, but real animals too. If you think of animals like the polar bear, there's water inside every cell of a polar bear and every cell of a fish. And so those are a couple examples of how water is inside animals and how animals use water. Okay, so now people, oh my goodness, let's go back to the FaceTime camera and talk about how people use water. Okay, well, one of the ways people use water is our bodies need it inside us. So we get a lot of water from the food we eat. Put this over here. Yeah, so I have a big basket of food. Oh, big heavy basket of food. And we're going to investigate the water that's inside the food that we eat because our bodies need water. And so we need to drink water. We need to eat foods that have a lot of water in them. So let's take a look at some foods and see what's inside, if there's any water inside. Well, I've got a bag of chips. I've got some salsa cheese. I got a piece of bread. Oh, let's take a look at this. And sometimes the printing on the back of, oh, I got some applesauce. Sometimes the printing, they always have an ingredients part on the label, and it tells you what's inside. So let's ask some questions. Do you think there's any water in applesauce? Well, if you take a look at the ingredients, mine says apples, and my second ingredient is water. So yeah, and if we were to open this jar, you know, it's kind of soupy, we can actually tell that, yeah, there's lots of water in apple juice. There's water in apple juice. So let's see, oh, I have a can of pineapple. When I shake it, I can almost hear the water that's inside. So let's check the ingredients again. Yep, pineapple juice, and about the third ingredient down is water. So yep, there's water in a can of pineapple. Oh, how about a can of beans? Oh, beans are vegetables. Pineapple is a fruit. So I would think that there'd probably be more water in the pineapple. But let's see. Let's read the ingredients on the beans. Ingredients, black beans. Second ingredient, water. So there's water in a can of beans. Oh my goodness. Oh, and here's some dressing, salad dressing. And I'm looking at the ingredients and water is the first ingredient in that one. Whoa, I can hear that. So there's lots of water in our foods. And oh yeah, can of pop, let's see, can of Pepsi here. Water is the first ingredient in that one too. So a lot of the foods that we eat have a lot of water in them, and that's good for our bodies. Okay, tomato sauce. Second ingredient, water. But let's for a minute take a look at the drier things. You know, I'm going to put these cans down beside me so they're not in the way. when we do some things. And I have, oh, you know, I didn't talk about this one, cheese. There's cheese in this. I wouldn't think that there's water in here. But when I look at the ingredients, it's the first ingredient. Can you believe it? The first ingredient in this can of cheese is water. Water everywhere. But, you know, I have some chips. I have some chips for that salsa, that cheese salsa. And I'm going to see, and it's so dry. It's a lot drier than some of those things I was getting out of cans. Let's see what happens if we crush up something that's dry. We eat a lot of things like potato chips and corn chips, and I am going to test out to see if there's any water in corn chips. I don't know. I'm gonna kind of, if you have a potato chips, you can do it with the potato chips. I'm gonna squeeze it. Remember how we squeezed some of the grapes and the blueberries? I'm gonna squeeze my chips. Oh, it's all dry and it's breaking into tiny pieces. Not too much moisture in things like potato chips. And our body needs to eat lots of things that have moisture in them. Whoa, cool. So I also have a piece of bread. Now, when I feel that, it doesn't feel gooey or sticky. But I wonder if there's any moisture in a piece of bread. That's a good question. So I'm going to take off a little chunk. And I'm going to see if I can mush it. Oh yeah, I'm getting crumbs. It's pretty dry. But you know what? It's kind of sticking together. As soon as I try to mush it, that bread is a little bit wet inside. There's a little bit of water inside of bread. Do you ever eat toast? That's how we take a piece of bread and kind of remove some of the moisture so it's nice and crunchy. And then we can put some jam on it and eat it. But yeah, if you set this piece of toast or a piece of bread out onto a plate all day and you came back later, you could feel that it has gotten drier because the water evaporated out of my piece of bread. Or you can do it fast. The fast way, you can toast it. So that's pretty cool. People get water from the foods they eat, but just how much water is inside us, you know, it makes us healthy. Every single cell that we have water in our skin, we have water in our blood. Can you feel some water in your mouth? Can you feel some spit inside your mouth? I can. So there's lots of water inside us. So let's do one last experiment to find out just exactly how much water that we have inside of us. So if you have a piece of paper and a couple of markers, maybe a pencil, if you don't want to do total markers, we're going to switch the camera one more time to see how much water we actually have inside us. So I don't need my hand lens anymore. I'm going to put my paper right there. So what I'm going to do is I'm going to put my hand down on my paper and I'm going to trace it. I'm going to trace my hand all around my fingers. And we're going to use this kind of art project to talk about how much water and how much of our bodies are actually made of water. Okay, so I traced my hand and now I'm going to use the marker, or you can just do it with the marker all at once, but then I get blue fingers. So there we go. There's one hand. So now I'm going to do my other hand over here. Okay, so I'm going to trace this one. Okay, all the way around. Oh, my thumb, that didn't turn out so good. And up the wrist and over. Okay, so there's my other hand, and I'm going to mark that with blue so you can see it better on camera. And this is kind of a cool science-y art project. And I'm making fingers with my blue marker. And now the color blue is going to stand for the water that we have inside us. So what I want you to do, there's about 70% water inside our bodies. So how many fingers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I colored 7 fingers blue, that would show us about 70% of our body has water in it. So I'm going to color 7 fingers blue. So first I'm going to do my thumb blue, that's 1. And I'm going to do my first finger blue, that's 2. And I'm going to do another blue thumb over here, that's 3. And another finger over here, that's 4. I'm going to color 7 blue fingers. Whoops. Okay. How much of our body is made out of water? 70%. So I got 4. Oh, time for another finger over here. 1, 2, 3, 4, 5. 5 fingers. 6 fingers. Oh, I didn't stay within the lines there. That's okay. 6 fingers. Now I'm going to color 1 more finger blue. Like, how about this one? All right, I like that. So there we go. 6 and 7 blue fingers. Okay, so now you can see the part of your body that's really solid and kind of dry and actually dry and crunchy like our chips and our bread. Our bones even have a little bit of water in them, and if they didn't, they'd break up like a potato chip. But there we go, let's count again. 1, 2, 3, 4, 5, 6, 7. Wow, 70% or 7 out of 10 parts of our body, all inside us, the water is 70%. So, and we could, we could use another color if you want to show, to make it really artsy and pretty, to show the parts that aren't water, they're more solid. And that's 30% of our body, or 3 out of 10. What is it made of water? But we're mostly water. Look at that. We're mostly blue. Mostly blue water. That's a fun art project to do. Okay, so back to my FaceTime camera. And there we go. So if you did the hand project, show me what you got. Or you can show me your gummy bears. Oh, look, you're still coloring. Great. Fabulous. And that's how much water we have inside our bodies. So plants need water, animals need water, and people need water. And these are just a few simple projects to do to show us how. So that's all I have for today. So I'm going to wave my blue hands goodbye. We'll see you next time on First Up Science. Something I had never ever seen before. And here's where you get to make a choice. Was it a giant Tyrannosaurus Rex? And I'm just gonna stick some pine cones in my box, and then the fun starts. I just start rolling them around. Air rushing out of the balloon is going to push that balloon up. So let's see what happens. All right, 1, 2, 3. Oh, wow. So that's how rockets kind of work. We are going to build 2 different kinds of rockets today.
Put the cork on its